Right now we will start a new topic. It's very important from basic point of view, that is chemical bonding. Chemical bonding. You know, except the elements present in group 18 having 8 electrons in their valence shell, you can consider group 18 atoms of element particularly present in group 18 having configuration NH2 NP6. So these elements have completely octet. Their valence shell is satisfied by 8 electrons, so they do not need to combine with any other atoms. But what about the rest elements? Rest elements, they do not have such octet configuration or 8 electrons in their valence shell. That's why they need to combine with other elements. They need to sharing their valence electrons with the other elements. Okay, or they can transfer electrons to other species to form a bond. So bond means it is nothing but an attractive force, that is called an attractive force which exists among the constituent atoms in a molecule, that is called chemical bond. So chemical bond means force of attraction. So I can write over here the force of attraction. The force of attraction which exists in between the constituent atoms in a molecule, that is called chemical bond. Next, if I consider particularly why a chemical bond is formed, why a chemical bond is formed. Okay, just I have told you, every atom needs to stabilize by acquiring 8 electrons in their valence shell. So that is, you can say, in order to get octet configuration. Next, that is, due to the formation of chemical bond among the constituent atoms, what happens? The entire system, or you can say atoms, combine to form molecules by means of chemical bonds. As a result, the net potential energy becomes minimum. That means they acquires low energy, particularly that is potential energy. That okay? Next, low energy means gains high stability. And once a system becomes stable, that means it is less reactive, possess less reactive nature. So these are the benefictions of as a result of formation of a chemical bond. So due to the formation of chemical bond, every atom gets 8 electrons in their valence shell, acquires low energy, gains high stability, and possesses less reactive in nature. That's why a chemical bond is formed. This is the main aim of formation of chemical bond. Next we will consider types of chemical bond. So it can be made on this basis. between two atoms of same molecule. One category is like this, and another category can be between two atoms of different molecule. Okay, so between two atoms of same molecules, the category of interaction can be, that is ionic bond, covalent bond. Next one you can consider metallic bond. These are the interactions or force of attractions that involve between the atoms of same molecule. Next, another type of bond is there, that is coordinate bond. And here this is one is your hydrogen bond, and another one that is van der Waals force of attraction. So these are the classification. We will discuss one by one, don't bother about that. Next, that is, we discuss what is the tendency of formation of a chemical bond. Okay, what is the tendency of formation of a chemical bond? Let us discuss through one example. Let us consider the formation of hydrogen molecule. So how it is formed? So this one is one hydrogen atom, and here this one I can designate it like HA, and here another hydrogen atom, this is like, you can say HB. That clear? So let's say here one valence electron is there, here also one valence electron is there. So tell me, whenever these two atoms approaches towards each other, then what happens? Here both force of attraction and force of repulsion come into play. You just see between this nucleus of this HA and this valence electron, that will be your force of attraction. I can write over here force of attraction, and between this nucleus and its valence electron, again here will be force of attraction. Then between this nucleus and this nucleus having similar charge, there will be force of repulsion, and between this electron and this electron similar charge, that will be force of repulsion. So what is the aim of formation of chemical bond? The net result should be force of attraction. You can say, since both opposing forces are interacting simultaneously, I can write over here the net result should be force of attraction. Then a chemical bond is formed. Okay, so they approaches to a certain standard distance at which the force of attraction predominates over the force of repulsion. So this is the preliminary condition of formation of chemical bond. So if you consider the further more closest approach, then again the force of repulsion will be predominate over your force of attraction. Okay, so once force of repulsion is predominates, if you forcibly if these two atoms brings more closer to each other, then what happens? Due to shortest distance, the repulsion force predominates over attractive force. At that moment, no chemical bond formation is possible. Okay, so it occurs at a certain closest distance, and that distance is called your bond length. Whenever this HH bond formation occurs, that means the force of attraction predominates over force of repulsion. That distance is called internuclear distance, and this distance is called your internuclear distance. As a result, the formation of hydrogen molecule takes place, and the net energy, the net potential energy of this system becomes less than that of isolated hydrogen atoms. Before the formation, there is the atom is called isolated hydrogen atom. Right now it has some amount of potential energy, but what happens whenever this hydrogen atom and these hydrogen atoms combines with each other in order to form a hydrogen molecule, then the net potential energy of the system decreases and the reactivity also decreases, and the system becomes stable, and hydrogen is very happy by getting 2 electrons. That is, here the configuration of hydrogen becomes, each hydrogen atom can be considered as 1s2 1s2. That is the nearest inert gas configuration of helium. So the system is stabilized. That is the condition at which the chemical bond is formed. That's why atoms combine to form molecules, except the elements, atoms of the elements present in group number 18. That clear? For example, if I consider the formation of sodium chloride, okay, so that is NaCl. So I have just discussed about its formation. The interaction is purely ionic, since it occurs between metal and non-metal. So loss of 1 electron by sodium, loss of 1 electron by sodium, that means it has a charge +1, so that +1 correspond to the valency of sodium, electrovalency of sodium, and Cl, chlorine, accept 1 electron. Okay, so Cl atom gains 1 electron and it having charge -1. So you can say the valency of sodium and chlorine having valency, univalency in nature. That's why NaCl is called a univalent electrolyte. It's called a univalent electrolyte. Similarly, if I consider magnesium chloride, MgCl2, so what is the valency of magnesium? That will be +2, and what is the valency of chlorine for each chlorine? That will be 1. That's why it is called a unibivalent electrolyte. Is that clear? Next, if I consider CaCl2, then what will be the valency of calcium? That will be +2, loss of 2 electrons, and chlorine having 1. So this is the concept of your valency in the formation of ionic bond. If you consider KCl, univalent electrolyte, potassium loss of 1 electron +1, chlorine -1. So this is univalent electrolyte, and valency of each species that is regarded as 1. Next we will discuss very important, that is conditions for the formation of ionic bond. Conditions for the formation of an ionic bond. An ionic bond. Since for the formation of an ionic bond, you need a cation and you need a anion. You need an anion. So first one, that is for the formation of cation, you have to remove 1 electron. So the energy responsible for it, that is your ionization energy. Okay, so low ionization energy is required in order to get a cation very easily. So I can write over here, that is low ionization energy. Low ionization energy is required to get a cation easily, to get a cation easily. Next, again there is also some non-metallic species which can accept that electron in its valence shell. So for that purpose you can say more the amount of energy released there, that means higher will be the negative electron gain enthalpy, or you can say electron affinity, that is high electron affinity. High electron affinity is required to get an anion easily. These are very two simple conditions for the formation of cation and anion. And the next one, that is, since these two oppositely charged ions are very close to each other, so there exists electrostatic force of attraction. That attraction is electrostatic, completely electrostatic. So there another form of energy is also there, that is called lattice energy. The energy that is released due to the interaction of oppositely charged ions, that is called lattice energy. And more the lattice energy, more will be the energy released and the potential energy becomes less. Okay, so we need high lattice energy. High lattice energy is required for the formation of an ionic compound. Ionic compound, is that clear? So between two charges, suppose the two ions are A plus and another one is B minus. So this lattice energy or lattice enthalpy, you can say, that will be given by 1 by 4 pi epsilon naught K, this is some constant, that will be into the charge of two ions. I can write the charge like Q1 Q2 upon radius of cation plus radius of anion B minus whole square. So that is the equation for lattice enthalpy. That means you can say lattice enthalpy or energy, that is directly proportional to the charge, is directly proportional to charge of ions and is inversely proportional to the distance between two ions, inversely proportional to distance or size, you can say ionic size. Is that clear? So this is all these are the favorable conditions for the formation of an ionic bond. So overall we can say, during the formation of an ionic compound, so the energy is responsible for the formation, that is first one low ionization energy, high electron affinity, and the third one that we consider just now lattice enthalpy, that is very important. So the net result, okay, so the net result, I can say net result for the formation of an ionic compound or ionic bond, you can say ionic compound, that will be ionization energy plus electron affinity plus lattice energy should be negative, that is energy should be released, then the formation of ionic compound is possible. Okay, next we will discuss the characteristics of ionic compounds. Characteristics of ionic compounds. Characteristics of ionic compounds. That is, first one, crystalline in nature. You know, all the ionic compounds exist in, mostly all ionic compounds exist in crystalline nature, that is true solids. That means ions are arranged so these are crystalline in nature, having that means oppositely charged ions are arranged in regular fashion, or you can say regular manner. Next, high melting and boiling point. High melting and boiling point. Since the constituent particles are oppositely charged ions which are held together by strong electrostatic force of attraction, so definitely they correspond to high melting and boiling point. And all ionic solids are very hard and brittle in nature. Hard and brittle in nature. And these are soluble in, since ionic bonds are polar covalent bonds, ionic bonds are polar in nature, so these are soluble in polar solvents, generally polar solvents, because in polar solvent, particularly water having high dielectric constant is taken as solvent for the solubility of ionic compounds due to its high dielectric constant. High dielectric constant means the solvation energy predominates over your lattice energy. In that moment, in this case, you can say an ionic compound is soluble in a particular solvent. Next, regarding their electrical conductivity. Okay, you know ionic compounds are good conductors of electricity in their fused, or you can say molten state, or you can say in their aqueous solution. Because you know in this state ions are free to move, that's why they conduct electricity. So these are few important characteristics of ionic compounds. Next, the second type of bond I need to discuss over here, that is a covalent bond. Okay, first write down its definition. The chemical bond which is formed by mutual sharing of electrons by two atoms, in which both the atoms contributes equally, is called a covalent bond. So here you see there is no shifting of electron, no transfer of electron occurs like that of ionic bond. Rather, the constituting atoms sharing their electrons. So nature of two atoms, you can say here, both the atoms are non-metallic in nature generally. Okay, so for example, if I consider the formation of hydrogen molecule, H2 molecule. You see one hydrogen atom, this one is one hydrogen atom having one electron. I can say hydrogen atom having one electron, I can represent like this, hydrogen having one electron with this cross sign, plus another hydrogen, see, having one electron. There is no difference between cross and this dot. I only represent here in order to distinguish. Okay, so this, the formation due to overlapping, what happens like this, two hydrogen atoms, one hydrogen atom, and here is another hydrogen atom. Okay, so here this electron contributes this cross one and this dot one. So likewise there is formation of hydrogen molecule. Right now this hydrogen having configuration 1s2, this hydrogen having configuration 1s2. So each hydrogen atom achieves the configuration of helium, and the number of electrons contributes, that is called covalency. Number of electrons contributes is equal to its covalency. So for hydrogen here the covalency is 1. Like that of, if I consider chlorine molecule, Cl2, Cl having 2, 1, the 7 valence electrons, another chlorine also 7 valence electrons. So next what happens, this one is chlorine, another chlorine, so this dot cross over here, I can represent all these electrons like dot. That clear? So formation of Cl molecule is there. So here each chlorine atom having covalency 1 because they contributes 1 electron each and achieve the configuration of, that is argon 288, that is configuration nearest inert gas configuration, that is argon. If I consider again HCl molecule, then it is easy. For HCl molecule, this is hydrogen, 1 electron, Cl, 1 electron, so overlapping is there, HCl, 1 electron from hydrogen, 1 electron from chlorine. Here you see the formation of HCl molecule is there. So each having covalency 1. Clear? Next, if I consider N2 molecule, just see, if I consider N2 molecule, or first one I need to discuss over here, oxygen molecule, that is O2 molecule. O2 molecule. Just see, oxygen, how many electrons, valence electrons, that is 6. That oxygen plus another oxygen I can write, also 6 electrons. So one oxygen and another oxygen, oxygen, so 2. So here these electrons, these 2 electrons get shared. You can imagine over here, that is 1 electron from this, 1 electron from this, and 1 electron from this, 1 electron from this. So there is formation of 2 covalent bonds there. There exists a double bond between 2 oxygen atoms like this. That clear? Next, if I consider nitrogen, you see how many electrons? That is 5 electrons. This is one nitrogen atom, another nitrogen atom, this is one nitrogen, this is one nitrogen. So here 3 bonds are formed like this, dot dot dot, and here. So this is one covalent bond, one covalent. So there exists nitrogen triple bond nitrogen, and these the pair of electrons which not participate in bonding, these are called lone pairs. lone pairs of electrons. This is the formation of covalent bond. Next, if we consider the characteristics of covalent compounds, characteristics of covalent compounds. First one, if we consider physical state, then most generally exist as liquids and gases in the form of liquids and gases. Next, that is their melting and boiling point. Melting and boiling point, just remember, less than that of ionic compounds, less than compared to ionic compounds. Next, I can say electrical conductivity. We remember electrical conductivity. These are covalent compounds these are bad conductors of electricity. Next, characteristics, that is solubility. These are insoluble in polar solvents like water. However, being soluble in non-polar solvents like carbon tetrachloride, benzene, etc. So these are few characteristics of a covalent compound. Next, the difference between ionic bond and covalent bond. Ionic bond, covalent bond. You know the difference. First one, that is it is formed due to the electrostatic force of attraction. Electrostatic force of attraction between two oppositely charged ions. And here it is formed due to mutual sharing of electrons. It is formed due to mutual sharing of electrons by two constituting atoms. Next, ionic compounds or ionic bond is non-directional, just an electrostatic force between two ions. But covalent bond, it is directional. If you compare their strength, then ionic bond is weaker than covalent bond. You can say over here, a covalent bond is stronger than ionic bond. Why? Because the shared electrons can't be displaced, and here you know there is no such sharing, rather it is an ionic force, which ions can be removed out easily. Next, ionic bond, it is polar. it is polar in nature. But covalent compound, if there is no electronegativity difference, then it is non-polar. It is non-polar when the electron negativity difference is 0. Is that clear? So if you consider examples, these are KCl, KNO3, NaCl, MgCl2, that clear, etc. These are the examples of ionic compounds. And covalent compounds, that is HCl, you can say CO2, H2O, etc. These are the covalent compounds. Clear?